Hello students, welcome to Sreenath Academy. In this video, we are going to discuss about the data handling, which is the fifth chapter from 8th class CBSE Maths subject. So I am Karthik. We are creating videos on all chapters on all subjects from class 1 to class 12. So why to wait there? Please do subscribe our channel, like our videos, share our videos. Don't forget to hit the bell icon so that you will get the immediate updates from our students. Okay. So without wasting time, we are going to start this session and with the overview of the chapter, and next we will discuss deeply about the chapter, and at the end we are having a summary session. So just listen students, we are not solving any exercise problems here. So exercise problems will be uploaded in the next series. So if you really want the exercise problems to be solved, so drop me a comment so that we are interested for the exercise videos, sir, so that if you get the enough number of comments, then we will surely upload the series on exercise problem students. And one more thing you have to remember, that is in addition to the classes, we are also providing the tuitions. So please go through the description, there is a number below, and contact to that number. You will make use the tuition students. Okay. And now the chapter name is data handling. Data handling. So this is the chapter name we are having now. So we will clearly see the overview of this chapter. That is looking for the information. It is the first thing we have to know about the data handling. And in that we are having the bar graph, pictograph, and the double bar graph, which we already know previously. We will just revise them. And organizing data. What is meant by data, and how data can be collected, and how data can be organized in a better way. So it is the representation of the data. The next thing is the grouping data. So how to group and why to group the data. So there is a grouped frequency distribution and ungrouped frequency distribution. What is the advantage of the grouped frequency distribution or the ungrouped frequency distribution? Okay, so we'll see all the concepts related to it. And in that concept only, we are having a subtopic that bars with a difference, and it is nothing but the histograms. Okay students, and after completing that, we'll discuss about new thing, that is the circular graph or the pie chart. Okay, so it is somewhat interesting to you students, so feel free to listen to it. And how to draw the pie charts, here we are going to discuss about the topic also students. So there is examples we are having, we are going to solve these examples, and that is the possible example. Next thing is about the chance and probability. What is meant by chance? A lucky chance and probability. Suppose you think today will not rain, and you didn't take in the umbrella, and you went to the started your journey to the school. Okay, and by the time of the evening you are returning back to the home. So when that time, what happens? Suddenly rain started and it is heavily raining. So what you will do? So your guess is misdropped. Okay, your chance, your guessing is missing. Your guessing is missing. So that is depends upon the probability and the chance. So getting a result. So all these terms we will discuss, that equally likely outcomes means what, and linking chances to probability. How to link a chance to a probability, and outcomes as a events, and chance and probability related to real life. So all these things which we are going to discuss now itself students. Okay, so give me a like and boost up the session, and we'll start the data handling chapter discussion students. Okay, so data handling. Okay, so looking for information. So in our everyday life, we will see so much of information around us, running around us. So this is the modern generation, is information is everywhere around us, and it is very easily to available, and it is very easily transforming from one place to another place. So the communication, which means the data transfer, which means the information transfer, is having many advantages. Okay, so if you suppose, if I am here right now and you are at some other place in different regions, but what happening is the students, you may see me, you may listen to me, So the information of about my picture and my thing is transferred to you very short time, very speedily. So it is nothing but the so highly the information is highly transferred in this present generation. So these are the basic things and we have to learn from the basics. Okay, students. So what are the information we come across if you open any newspaper like that? So the Rahul Dravid or anything, Sachin Tendulkar or like that, any batsman scored this much of runs and this bowler bowled have taken that much of wickets like that. So runs made by a batsman in the last 10 test matches, a number of wickets taken, and the marks scored by the student in mathematics text. Okay, in exam, and the storybooks of your friends, so like that. So the information in all these cases is called as data. But it is, students, the information in all these cases is called as data. We call data is nothing but the all collected information, all collected information. So that is the data definition, students. So normally in many situations we will collect the data. Okay, for example, a teacher may like to ask you that average height of the students in a class. For that, she will make a note of the all the heights of all the students. Okay, in the class. And sometimes the data may be represented graphically, maybe in a tabular form, maybe in normal forms. Okay, students. So if it is represented in a table form, it is somewhat clear and good to represent, and if it is graphically, and it is more convenient, students. Okay, suppose uh, pictograph, this is the representation of data which we have discussed in our previous class, students. Okay, suppose here there is a picture of car and it equals to 100 cars. This symbol equals to 100 cars. So in the month of July, okay, so there are two cars and half car. Okay, which means two cars means so 50 to 100 car and 100 cars, 200 cars, and there is a image of half car which means and 50 cars. So finally after adding all we will get 250 cars. Here there are three cars, so for each car 100, so how many? 300 cars. Now here we are having four cars, so each car is 100 car, represents 100 cars, so finally 400 cars. So this is a pictorial representation of the data using these symbols, students. Okay, and by seeing this we can tell the answers. How many cars were produced in the month of July? In the July, 250 cars. In which month were maximum number of cars produced? In the September, maximum number. And next thing is the bar graph. So it is another way of representing the data, students. Okay, so here the information is displayed using the bars of uniform width, using the bars of uniform width. Okay, so the width is same and the length of the bars corresponding to the it is proportional to the respective values. So it is the graph. So it is the academic year 2003 to 2004 and 2004 to 2005, 2005 to 2006. So these are the academic years, and here is the number of students in class 8. Okay, the lengths of these equal the lengths of these represents the number of students in class 8 or class like this. So its length is representing this much of length is having, so it is representing 100. So how many students are there? 100 students are there, like that, students. So in which year is the increase of the number of students is maximum? In which year there is the large number of students has increased? So if you see, that is in the 2007 to 2008, there is more number of students are there. Okay, and in which year is the number of students maximum? In which year? In this year it is the maximum students. So the number of students during 2005 to 6 is twice that of the 2003 to 4. Is it true or not? We have to tell it. So the number of students in 2005 to 6, it is this value, and it is double the number of students in 2003 to 4. Yes, it is true, students. Like that we can get some information, get some clarity, like that, students. Next thing is the double bar graph. So it is useful to compare particularly two things in different areas. Suppose here it is there to represent to compare the marks in different subjects, to represent the marks in different subjects for the 2 academic years. So this white color is for academic year 2005 to 6, and this dark color is for the academic year 2006 to 7. So 2 academic years marks, subjects marks can be compared at a time. So if you see here, the maths subject marks are compared for the 2 academic years, and the science subject marks are compared for the 2 academic years. The science and the social science and the English and the Hindi. So every subject marks are compared. Marks are compared. Okay, students. So this is the information given by double bar graph. Okay, like that. So if you see in which subject the performance, as the performance improved the most. So in which subject the performance increased most in next academic year. If you see in the math subject, if you see the performance increased very high. It is the 2005 and it is the 2005 to 6, it is the 6 to 7. The percentage increased very high. So the increase is small here, small here, small here. There is no increase in Hindi, there is decrease in English, there is small increase in science, and there is small increase in social science. But in the maths there is a sudden increase. There is a sudden increase. And in which subject the performance deteriorated, which means performance decreased, if you observe in the English subject. And which subject is the performance at par? So if you see, it is the performance is normal, students. So these type of informations you can get from the double bar graph, students. Okay, so these are the advantages we are having. Next, organizing data. So data means collecting the information. So collecting is good, and it is the raw data if we collected at the beginning. But so usually data available to us is an unorganized form. So normally data available is in unorganized form, and it is called as the raw data. Okay, unorganized form, and it is the raw data. Okay, students. So it is the raw data and it is the unorganized form. Okay, students. So organizing data. So whether we have to organize the data, students? Yes, of course we have to organize the data. So how to organize it? Before knowing it, why to organize it? We will answer that question. Suppose, for example, a group of students were asked their favorite subject. What is their favorite subject? So these are the lists they have told. So one told it arts, mathematics, science, English, mathematics, art, English, mathematics, English, art, science, like this. The information is collected and it is the raw data. So it is not organized. It is unorganized. What is the problem with it? What is the problem with it? So now if I ask you one question, can you tell you the answer within seconds or within minutes? Which is the most liked subject and which is the not liked subject? By seeing it, can you directly tell? By seeing it, which is the most liked subject, can you tell? No, it takes some time, mathematics, or to compare which subject is, how many times which subject is repeated. So this is the problem with the raw data and organized data. Suppose if I organized it like this, it is the subject art, mathematics, science, and English. It is the tally marks. So how many students are liking it? So number of students, 7 students, 5 students, 6 students, 4 students. I have made it as a group data. I have organized it in a table. So by seeing this table, if I ask you a question, which subject is mostly liked, you can shoot shortly within second. You can say that is the art subject is mostly liked. Why? Because 7 students are liked. And which subject is not liked? You can simply say that English is not liked. 4. Number of students are 4. So this is the difference you will get when you organize the data and when you not organize the data. That is the difference between the organized data and the unorganized data, students. Okay, so that's why we have a need to organize the data in a better way, in a best way, students. Okay, like that. So here the number of students, it is called as the frequency of that subject. How many times it repeats? Frequency tells how many times it repeats. It is the frequency. Okay, students. So it is the frequency distribution table, which we call as the frequency distribution table, students. Okay, next. So we have understood the we have understood the need for the organizing data. Okay, so how to organize the data? So there are some different ways to organize data. So okay students, grouping data, so it is the one of, so we have to group the data. Okay, rather than to leave it as ungrouped data, we have to group data. It is better way of organizing the data. Okay students, so the data regarding the choice of subjects, okay, of each entries, like art is liked by 7 students, max is liked by 5 students, and so on table 5. This information can be displayed, that information can be displayed pictographically, bar graphically in table form. Okay, but if it is data is much more large data, suppose the marks out of 50 marks is for out of 50 for students in mathematics by 60 students of 8th class are represented like so. These are the marks out of 50 for the 60 students. Okay students, so these are the marks. So if you make a frequency table for these marks, it is somewhat good, but it is becomes too heavy. Why? The number of observations, number of students are 60, so it is too much heavy. If you make a frequency distribution table, simply a frequency distribution table just as like this, so we have to think in another way, a new approach to make more easier, to make much organized. That is, the best way is to form the groups. We have to group the data. How we can group is, we have make simple inter-class intervals, that is from 0 marks to 10 marks, from 10 marks to 20 marks. How many students got the marks from 0 to 10, or the how many students got the marks between 10 and 20? How many students, instead of how many students got 0 marks, how many students got 1 mark, how many students mark 2 marks, how many students got 3 marks? It is the previous table, ungrouped data. It is principle for simply frequency distribution table. Instead of this, the data is very large now. What we can do is, how many students got 0 to 10 marks, how many students got 10 to 20 marks, how many students got 20 to 30 marks. It is the better approach, better organization, so that we can group. By grouping it, the length is decreased and we can easily organize it. Like that, we have grouped the 0 to 10 and the 10 to 20 and the 20 to 30, like that 50 to 60 marks, 50 students. Like that we have grouped them students. Okay, how we have to group is depends upon our needs and our questions and our outcomes. It depends upon how we have to group means, and how many tally marks, how many frequencies, like that we have to represent students. So here it is called as the grouped frequency distribution. Previous thing is the frequency distribution, just there is only frequency concept, frequency distribution. Now it is the grouped frequency distribution. Now it is the grouped frequency distribution. Now it's the time for grouped frequency distribution students. Okay, and it is the grouped frequency distribution now itself. Okay, and the grouped frequency distribution, we made classes, class intervals. We make class intervals. Okay, so class intervals, if you see 0 to 10 is one class, 10 to 20 is another class, 20 to 30 is another class intervals students. So these class intervals have limits, lower limit, upper limit. So lower limit and upper limit, lower limit and upper limit. These are the class intervals. Here having the lower class limit and the upper class limit students. Okay, and these classes have the class width or the class size. So class width is depends upon the upper limit minus lower limit gives us the class width, how much range is there. Okay students, these are the terms related to the frequency distribution, grouped frequency distribution students. Okay, and next thing is bars with a difference, bars with a difference. So let us consider the grouped frequency distribution of the marks. So just previous example we considered students, we are representing it with bars. Okay, grouped frequency distribution. So of the marks obtained by 60 students in mathematics, marks obtained by 60 students in mathematics students. So class interval is 0 to 10, 10 to 20, like that. Frequency is 2, 10, like that, students. Okay, so on the x-axis we have taken the marks of the students, 0 to 10 marks, 10 to 20 marks, like that. On the y-axis we have taken the number of students. So here the class width is same. For that the bars width is also same. And the length of this bars represents the frequency. The frequency, students. And if you observe this, what is the difference? What is the difference you are observing while doing this rectangular things is, it is not the bar graph, but what it is the histogram. Histogram. Sir, what is the difference between the bar graph and histograms? So in the bar graph, there is some spacing between each bar. There is some spacing between each bar. But here, if you observe, there is no spacing between the bars. Bars are closely spaced. So that is these are the continuous bars. This is the difference between the histograms and the bar graph. Okay. So this is the histogram. And bars of equal width, and there is no gaps between the bars. And height represents the number of students. And there is a clink, a broken line like this. So it represents that from 0 to 20 there are a lot of values, but they are not having anything. That's why we have just neglected them. Okay, students. How many teachers? So like that to do this, students. Next thing is about the circular graph or pie chart. And it is pie chart. Pie chart. Pie chart. So if you see here, it is the circular, the information, the data is represented in the circular form. The data is represented in the circular form, students. Okay. Data represented here in the circular form. So if you see here, that is the time spent by a child during a day. So during a day, a child spent her time in all these things. And this is the age group of peoples in a town. In a town there are peoples and they are having the age groups. So age groups of people. So these two are representing so much of data, and so goodly, so easily they are representing so much of data. These circle graphs are called as the pie charts or the pie graphs. Okay, students. So it shows the relationship between the whole to the part of it. It shows the relationship in between the whole to the part of it. Whole to the part of it. Okay. You see here, the whole circle is divided into some parts, some sectors. We have discussed about the circle, and it is the center, and it is the radius, and it is the diameter, and this is the sector, and the segments, radius, arc length, length of the chord, all these related stuff. Okay, students. So the size of each sector, if you see, this will shows the relationship between the part, which means the sector, to the whole circle. Okay, students. Suppose for example, the proportion of the sector for hours spent in sleeping. So what is the out of the total hours, how many hours she spent in sleeping? If you see, the number of sleeping hours is 8 hours. Number of sleeping hours is 8 hours, and the total hours is 24 hours, which is 1/3. Okay, so in the whole circle, 1/3 part of the circle is represented by sleeping sector. If you see, it is the half, and it is the 1/3 of the sector is represented by the sleep, students. Like that. So 1/3 part of circle is drawn like that, students. Okay. So the proportion of the sector for hours spent in school. So how many hours he has spent in school? If you see, it is the 6 hours. So 6/24, which is 1/4. So 1/4 part she spent in school. Okay, students. So we have to represent like that. So sector is 1/4 part, students. Okay. Next, drawing the pie charts. How to draw the pie charts? So if you see, students, so ice creams are having different flavors. Here we are having the flavors of chocolate flavors, vanilla, and other flavors. Okay, percentage of students preferring the flavors. So how much percentage of students are preferring the chocolate flavor and how much percentage of students are preferring the vanilla flavor and remaining flavors? If you see, look at here, the chocolate flavor is preferred by 50 percentage of the students, and the vanilla flavor is preferred by 25%, and the other flavors are preferred by 25%. So looking this, we have to construct a pie chart. How we can do it? So for that, basically the circle is containing the 360 degrees of angle, 360 degrees angle, which is the whole, out of which we have to give each sector some angle according to these values, friends. Okay, for chocolate it is the 50% students. So 50% means it is the 50 by 100, which means 1 by 2. So 1 by 2 of the total angle is has to be given to the chocolate. So that is nothing but 360 degrees by 2, which is 180 degrees angle we have to give to the chocolate. And for vanilla it is 25%, which is 1 by 4, which is 360 by 4, that is 90 degrees angle we have to submit to the vanilla, and another 90 degrees to the other flavors. How we draw is, first you have to draw a circle and we have to mark a center on it, and we have to draw a radius on it. Okay, so if you draw a diameter to the center, you will get the 180 degrees of angle. Here we need 180 degrees, so 180 degrees, so we can give it to the chocolate. And what is our aim is, we have to mark other sectors, another is 90 degrees. So we know this is another 180, and we have to make two equal halves, so that this will be 90 degrees and this will be 90 degrees. This is for vanilla and this is for other flavors. By doing simply this happening, students. Okay, so there is the examples we are going to see, students. Example 1, there is a joining pie chart here, the expenditure of various items and the savings during a month. So on which item the expenditure was maximum? So if you see, for the transport they spent the 5%, and for the others they spent the 20%, and the 15% is saving, and the clothes is 10%, food is 25%, education is 15%, house rent is 10%. Out of all these things, on which their expenditure is more? If you see which is more, here the food, which is the 25%. Food is the 25%. Expenditure on which item is equal to the total savings of the family. So what is the savings? 15% is the savings. So to which area of expenditure equals to 15%? So educational for child. So child education is again 50%. Next, if the monthly savings of the family is 3,000, if the family saves 3,000, what is the monthly expenditure on clothes? Here the tricky question is there. So the family is spending, suppose if the family is saving 50% of the money, so that 50% of money is equals to 3,000, then 15% of the money is 3%, then how much money they're expending for clothes? So in order to know the percentage of the clothes, first we know the how much amount, what is the total amount they are getting. So that is how we will get is, that is 15% is equal to 3,000. So which means how we can get the total amount? Basically normally we will say is some amount. Normally how we will do is 15% is how we will get this number is, and how much some amount into 100, like this we will get students. So simply we can do it as 3,000 is the amount they are spending, and divide by 15, it is the 15% into 10. If you do like this, you will get the 2,000. It is the 2,000, which is the 10%, students. It is the 10%. 2,000 they are spending, students. Like that you will get. And solve this example by your own, students. Chance and probability. So this is the interesting thing, students. So I have already told you. So that is the rainy season where happening. Okay, during the rainy season you will carry a raincoat every day, but one day what we are doing is that, students, we are not what we are doing, we didn't take the umbrella or raincoat. we think the today will not be rain, but what the problem is that students, at that day only, at that only what happens, rain has came. At that only rain has came, it has rained heavily on that day itself. So at that day, on that day, it has rained heavily. So because of it, what happened? As it is the raining heavily on that day, what happened? You didn't take in the umbrella, so you you are stuck in the rain, students. So your chance, and sometimes we will prepare 4 chapters out of 5 chapters, and you will leave 1 chapter. But what happens in the exam? The question will comes from in the 5th chapter. Major questions will come in the 5th chapters, and which we are left from that portion itself only. What happens? Questions has came. Okay, students. So these are the things. Sometimes what we accept, what we expect will not done. We expect something, but it will not be work done. So these are situations. So we say, oh, our chances has missed, we misguided, or our guess is missing. Okay, students. So sometimes we buy a ticket, train ticket, which is waitlisted. We hope that it will be get confirmed. So how much chance is there to get confirmed? We don't know. So there is some chance to get confirmed, and there is not having full chance to get confirmed. There is some equal chance or not equal chance. There is some probability like that, students. Okay. So getting a result. So you might have seen that if the before cricket match starts, they will take the toss. So whenever the toss is getting on, who will win the match? Do you know? We don't know. Who will win the toss whenever it is going, whether it will finds the head or tail? We don't know. So in a random experiment, what the outcome we are getting, whether it may be head or the tail, it is called as the result of that. It is called as the result or the outcome of that experiment. Suppose if you are having the dice, you throw it, you may get 1, 2, 3 or 6, whatever it may be. We don't know. Anything we can get. Anything we can get, friends. Okay. So in the tossing, or in the case of dice, or in anything, what we get, we don't know. Okay, students, in these random experiments. So that is happening. Equal likely. So these are the outcomes, and equally likely outcomes means what? Suppose a coin is tossed several times. It has tossed 50 times, and the tally marks are there. And number of heads we got is 27 heads, and number of tails we got is 23. And if you have tossed 60 times, you are getting 28 heads and 32 tails. If the number of toss increasing, so the number of heads and the number of tails are becoming very, very closer. So if the number of tosses increasing, the number of heads and number of tails are equaling. So here the possible outcomes are two only. One is the head and another is the tail. These are the two possible outcomes. Possible outcomes. These are the two possible outcomes, and these probability or the chances of these outcomes is becoming almost equal whenever the number of tosses are increasing. So how much chance is there to head, and how much chance is for the tail? Both are same. Okay, students, these are happening, students, in the case of dice also. So what we can think is the students, so there is a equally likely chance or the probability for all outcomes. In the case of how much probability is there for head is the same probability for tail. In the case of dice 1, 2, 3, 4, 5, 6, how much probability for 1 is equals to how much chance is from 2, and how much probability for 6. That is happening, students. Linking chances to probability. Okay, we are linking the chances to probability. So there is an experiment of tossing a coin. We have tossed a coin. We are getting the outcomes, head or tail, like that. What is the probability of getting head, which is 1/2? What is the probability of getting tail, which is 1/2? Just now we have discussed both are having the same equal probability. Same equal probability, students. Okay, and coming to the dice. So what is the probability for 1? What is the probability for 2? What is the probability for 2 means it is the probability of 1 by 6. So it has a chance of 1 out of 6 outcomes. Total outcomes are 6, out of it is having a chance of 1. So how many outcomes, how many chance for 2? It is also 1 by 6, it is also 1 by 6. So every outcome is equally probable, every outcome is equally likely. Okay students, so in the case of dice, the probability is 1 by 2 for each outcome, and the case of dice, the probability is 1 by 6 for each outcome. Outcome as events. So each outcome of an experiment or a collection of outcome called and make an event. Okay students, if you have tossed the coin and you get the head, it is an event, it is an event. And we have planned something, so I want to get only heads. What is the probability? 2, 4, 6. In the case of if you want to plan to get only even numbers in the case of dice, then 2, 4, 6 are the outcomes. So these are the events. Outcome is an event students. So we'll do this task. A bag has 4 red balls and 2 yellow balls. 4 red balls and 2 yellow balls. Both balls look identical, no change in size, no change in anything, only the color is difference, and they're in a bag. So how many balls are there? Total 6 balls in there. So, and we have to pick one ball randomly. So what is the probability for red ball? The red ball probability means how many red balls are there? We're having 4 red balls out of 6 balls. Out of the 6 balls, 4 are red balls. The probability is 4 by 6, which is almost 2 by 3. And what is the probability for yellow balls? There are having only 2 balls out of the 6 balls. The probability is 1 by 3. That's it students. Chance and probability related to real life. So we talked about the chance that rain may comes or rain may not comes. And we have talked about the probability that it may head, it may tail, like that students. Okay, and the probability that it may be one, it may be one, in the non-rainy season, it may be 1 by 10th probability. Okay students, like that. So to find the characteristics of large group by using a small part of group, for example, during elections, exit polls is taken students. So there are people there, and after voting they will ask at the sentence to which leader we have voted, so they will raise some hands. So by that we will get some predictions. So chance of getting this leader, chance of getting this leader, like that happen. And finally our chapter is completed students. Finally our chapter completed. Hope you have understood well students. So if you have any doubts, please feel free to comment us, please feel free to reach us students. We are always there to help you, support you. And hit the bell icon and use the tuitions, and if you want the exercise problems, just drop a comment. So now we will see the data handling chapter summary students. So first thing is the information can be represented in the pictographs and in the bar graphs and in the double bar graphs to compare, to get some inferences. And organizing data is very important so that we will get easily, and frequency is the number of times it comes. And grouped data, for a very large data, it is better to group the data. It is the grouped frequency distribution. They are having the class intervals, lower class limit, upper class limit, class width is there. And it is the histogram. There is no space between the bars, and the length represents the frequency. And next thing is about the pie chart students. So pie charts, these will show the relationship between the parts to the whole. So it is the circular shape, and we can draw the pie charts. Pie, there is having the total angle is 360 degrees, and we have to give the angle also related to the how much part it is there. And we have discussed about that and solved some problems. Next thing is the chances and the probability. So getting a result in a random experiment, what you are getting is a result, and every outcome is equally possible, equally likely, equally chances. And if your event means outcome which you are getting, and probability we have discussed clearly about that. So summary of this session is also completed students. So all the best for future exams. Have a nice day, keep smiling. Bye bye students.